So I just want to present the solution to the 4 assignments that we ask you to do. So the first assignment, if you remember well, was concerning Senegal and the rice market with an assumption of a small country, that is to say without any power on the world market, homogeneous goods and linear forms, functional forms for the demand and supply functions. The second assignment concerned Senegal rice market, and so the modifications was the fact that it was now an isoelastic functional form for supply and demand. The third assignment was about a change in the small country assumption for a larger country assumption, that is to say Senegal exerts market power on the world market. And finally, the fourth assignment was about the introductions of differentiated goods. So here is the file, the GAMS file, which is solutions to the first assignment that we gave you. So the file starts with comments about the program between the instruction $on-text and $off-text. So it's always important, you know, to explain what this model is about, what are the technical details. And here also you've got, of course, some property right issue and also a waiver, because I do not want this model to be used for economic policy recommendations. It would deserve much more investigations, in particular in terms of econometrics. So declarations of parameter. So this is the beginning of the program, with in fact the 4 parameters necessary for the demand and supply function, the exogenous variable, the custom duty, T, and then you've got 6 parameters which consist in the name of the variable. So for example, local price, local demand, followed by a 0, which means that these parameters are for initial value of each variable. Okay, and then you've got the entry of data which are necessary for the calibration of the model. So they come from either the trains database from UNCTAD or the FAO stat database. Do not forget to explain the units of this data. So for example, here prices are in US dollar, supply and demand in tons. Okay, so you've got only 4 data to enter here in this program, and then you've got the slopes of the demand and supply function, which have been calculated to reflect local elasticity, equivalent to elasticities from an article that I found out from a review of literature. And then you've got the calibration part. So this is a very important part of the program, because of course you have to give value to all parameters which are necessary in the model. But you've got a specific order to respect, because of course, for example, you've got to give a value to P0, okay, before giving a value to C, because C necessitates a value for P0, okay. So it's very important to follow a strict order in the calibration process, and at the end of the calibration process you must be sure that every equation of the model will be strictly respected. Of course, you have to give initial value of the variables. So it means that just after declaring the variables, the 6 variables with a comment, you've got to initialize the variable. So for example, the first instruction means p.l, which means, well, the current value of p, the variable p, is equal to p0, which is a parameter that I gave a value just before. And so you have to give value to each of the 6 variables of the model. Then declarations of equation. So here it's very interesting to give a specific name to each equation. So it is EQ underscore the name of the variable which is determined by this equation. So for example, the first equation is an equation which determines local supply of rice in Senegal, and so the name of these equations is EQ underscore XS. So just after declarations of equations, you've got the model with 6 equations. And here you have the name of the model, tariff, and this model consists in all equations which are present in the file. So you've got the 6 equations which are just above this instruction. So it means that you can use the instruction all between 2 slashes. And then you've got 2 solve. So the first solve is without any shock. So it is just to check that initial infeasibility is 0. So it means that with this solve, we will check that each equation is respected. That is to say, for each equation, the left-hand side member is equal to the right-hand side member. Then the shock. The shock is applications of a 20% import duty. And then you've got the solve. And so the second solve, you must have an initial infeasibility which is different from 0, because it means that for the third equations of the model, P is equal to PE multiplied by 1 plus T. This equation will be no more respected, because right now T is equal to 20% instead of 0. And then you've got the results. So I declare some parameters. These parameters are growth rates of some variables. Of course, you can add other growth rates of variables. So for this growth rate of variables, so it is defined in percentage. So I multiply by 100. And then it is rate of growth. And so it's final value minus initial value above initial value. And for the final value, of course, at this moment, this is xd.l, because it's the current value of the variable xd, which is here the final value of the variable xd. So after that, I just want to ask a display of all these variables of the current values of the variable xs, xd, md, and so on, and also the value of the parameters. And then I declare parameters which are variations of surpluses and variations of public revenues and of welfare. It is defined in US dollar billion, so it means that in the formula that for sure you will recognize, because it's very simple formula for calculations of surpluses. In fact, you've got divisions by 1 billion, which means that we will have the variations of surpluses and public revenue and welfare in US dollar billion. And so right now, if I press this button, Run GAMS, you see that we are now in the process window. So I just want to start with looking at the top of this window. You see that the first solve, there is an initial infeasibility which is equal to 0. So it means that just after definitions of the model, we are sure right now that each equation is respected. And then there is a shock, and there is a second solve, and then you've got an initial infeasibility which is strictly greater than 0 because it is 114. Okay, and then in 2 iteration you've got a feasible solution to a square system, and with these new values for the variables of the model, the total infeasibility of the model is 0. So it means that all the equations are again respected. So I can double click on this line, the blue one in bold, and so I've got the LST file. And so concerning the LST file, you will check that there is 6 single equations and 6 single variables, so it is a square system. And then you've got the results here. So you've got the value of the final value of the variables, of 3 variables. And you've got the rate of growth of imports. For example, it is here TXCMD, which is equal to minus 13.7%. So it means that imports are decreased. Then the local price is increased. Then there is a protective effect on local producers because there is an increase in the local rice supply and a decrease of the local rice consumptions, which is quite normal because there is an increase in the local price. And then you've got the value for the variations of consumer surplus, producer surplus, public revenues, and welfare, which is in fact the sum of the first 3 terms. So consumer surplus is decreasing by $205 million US. It's normal. It's the fact that consumers consume less and at a higher price. And then you've got an increase in the producer surplus by $83 million. And then you've got public revenue, which are increased by $113 million. And then if you add these 3 terms, you've got the variations of welfare, which is negative by $9 million US. So your recommendations is not to activate this policy. So let me present right now the solutions to the assignment concerning implementations of an isoelastic functional form for demand and supply functions. So you've got here the program that is corrections of this assignment. So if I show you the new model, you notice that the change concerns the way the supply and demand functions are written, because right now you've got an isoelastic relations between supply and local price and demand for rice and local price. So this concerns these 2 equations. The rest of the model is unchanged. So of course it means that you've got to change the calibration process, because right now what happens is that you've got an entry of elasticities. So you can in fact enter directly elasticities from Combaté, Cofitesio and Diane, so the one that have been found by these econometric investigations. So you've got B is equal to 1.5 and D, which is equal to 0.4, which are the elasticities that you have previously declared, of course. And once you have entered the value for these elasticities, you can calibrate your model. So you have to calibrate the size parameters. A is equal to xs0 over p0 at the power b, and c is equal to xd0 over p0 at the power minus d. So you have given a value for all parameters, and you are sure now that at the end of the calibration, when you will have initialized the variables, in fact, the model will be initially well calibrated, that is to say, initial infeasibility will be equal to 0. So the rest of the program is unchanged. So if I make a run in the process window, you can notice that for concerning the first shock, the initial infeasibility is equal to 0 or very close to 0. It is 2 times 10 at the power minus 10, so it's very, very small. So the model is well calibrated. The second shock, the initial infeasibility is 114. So it's positive, it's normal because now the tariff has changed. So in 2 iterations, the GAMS solver finds a solution. So if you look at the solution, you can have a look at the solution. So you've got here the impact of the tariff. So first it decreases imports. It's normal because imports are more expensive. So it means that the local price is augmented by 20% because the world price is unchanged, and so the local price is augmented by the level of the tariff. So if the local price is augmented, you've got a decrease in the domestic demand for rice because rice is more expensive. And of course, as the local price is augmented, you've got an increase in the local productions of rice. You've got also variations of consumer surplus, which is negative because they consume less at a higher price by $206 million. The producers, their surplus is augmented by $96 million, and the public revenue are augmented by $90 million. It's normal because it's due to the impositions of the tariff. And if you add the 3 elements, variations of consumer surplus, variations of producer surplus, and variations of public revenue, you conclude that the variations of welfare is negative. It is minus $20 million. So your recommendations is not to apply this policy. Now I'm presenting the corrections to the third assignment, which concern, in fact, implementations of a large country assumption. So if I show you the model, so it's here. So the new model is all equations are kept except one, which concern, in fact, the relations between supply of imports and world price. So right now, in fact, before it was PE is equal to PE0, that is to say the world price is unchanged. Right now, so you must have a change in the world price if imports are changed. So in fact, the producer from the rest of the world accept to increase their supply of rice to Senegal if there is an increase in the world price. And so you've got after that demand for rice of Senegal, of imports of rice, is equal to the difference between local demand and local supply. So it's normal, it's the definitions of imports. And the last equations is in fact the determinations of the world price. Demand for imports is equal to supply of imports. So you've got something which is in fact only changed because of these assumptions of large country. So of course there is now a change in the calibrations because you've got a calibration of the size parameters of the supply function for rice, which is f is equal to md0 or ms0 over PE0 at the power E. So we have, I have entered here an elasticity of 60 for this import supply. So it means that for a change in the demand for imports, there will be an increase in the supply of imports by with only a small variations of the world price, because this elasticity is very large. Okay, and so of course before that we must declare the new parameter E, the elasticity of foreign supply, and of course of F, the size parameters of the foreign supply of imports. Okay, so nothing else has changed. So what we can do is to run the program. So we are in the process window. The initial infeasibility is very close to 0. So it means that the program is correctly calibrated and initial infeasibility is very small. And then the second solve, you've got an initial infeasibility which is 114, which means that right now there is one equation which is no more respected because the tariff has changed. It's normal. So if you look at the results, in fact, you can look at the results, and so you notice that, well, you've got a decrease in imports. This is because of the tariff. They decreased by more than 30%. And so the big change right now is that the world price is slightly changed. It decreases by 0.6%. So it's normal because Senegal decreases its demand for imports to the rest of the world. And so as demand is decreased, the world price is decreased. So it means that the local price is increased because of the tariff, but less than 20% because of the slight decrease in the world price of rice. And then with this increase in the local price of rice, you've got a decrease in the local consumptions of rice by something like 7%, and an increase in the local supply of rice by something like 30%. So it means that the consumers are hurt by this policy. They lose 199 million US dollars. The producers are positively affected by this policy by 92 million dollars, and the public revenue increased by 91 million dollars. And so if you add these three components of welfare, you've got a national welfare which is decreased by 16 million US dollars, which means that you must not recommend this policy. So here is the program corresponding to the fourth assignment, which was introductions of differentiated goods. So if I look at the model, so here is the new model here. So you've got 7 equations. So you've got 3 equations which are concerning the market for local rice, and 3 equations concerning the market for imported rice. And the final one is the price linkage, which is the relations between local price of imported rice and world price of imported rice. So concerning the market for local rice, you've got supply functions which is unchanged, but the demand functions is modified, because right now the demand for local rice depends on the local price of local rice, P, but also local price of imported rice, PM, which is the substitute. So it means that the relations between XD and PM is positive when the price of imported rice, local price of imported rice, is increased, the local demand for local rice is increased because, in fact, consumers are less interested by the consumptions of imported rice. And the third equation concerns equality of demand and supply. This is the determinations of the local price of local rice. Then the market for imported rice. So you've got MS, the same relation between MS, the supply of imports, and the world price. But you've got the demand for imports, which is modified because right now demand for imports depends on the local price of imported rice, PM, under a decreasing relations. And also it depends on the local price of local rice, which is the substitute, and the relations is positive when P is augmented, MT is augmented, because consumers are less interested in the consumptions of local rice, and so they turn on the consumptions of foreign rice. And the third relations, which is equality between demand for imports and supply of imports. So the beginning of the program, the big change concerned the calibration, with the calibrations of the size parameters of both demand functions. So you notice that you've got at the denominator two prices at a power. So you've got to write brackets to be sure that all this is at the denominator. So the end of the program, we do not make a welfare analysis because it's more complex. We do not have enough time to explain how to do it. So if you want to do a welfare analysis, you must check this reference, which is a book by Just, Ueth, and Schmitz. It's a very good book entitled The Welfare Economics of Public Policy, and it explains how to make this welfare analysis with two substitutes. So let's see the results. So you see that the first solve you have an initial infeasibility which is 0, and the second solve you have an initial infeasibility which is 114. So if I look at the results, well, you've got the results which are here. So it means that with the applications of a tariff, imports are decreased because they are more expensive. So the demand by Senegal of rice on the world market is decreased. So the world price is slightly decreased by 0.2%. And so the local price of imported rice is increased by less than 20% because on one side you've got a tariff, a tax of 20%, which is implemented. On the other side you have a slight decrease of the world price. So the local price of imported rice is increased by less than 20%. So it means that with this increase in the local price of imported rice, consumers are less interested by imported rice, more interested by the consumptions of local rice, which is increased by more than 10%, which means that the production of local rice is increased by more than 10%. And with this increase in demand, you've got an increase in the domestic price of rice. So be careful that, of course, the consumptions of local rice is increased, but it's not positive for consumers because, in fact, the big effect is an increase in the price of imported rice, which implies a decrease in the consumptions of imported rice. And so by default, consumers turn on the local rice. And you notice that both prices are increased, which is not good for consumers. Of course, the local producers are benefiting from this policy because in fact, the local price of local rice is increased, and so they increase their production.